Okay, so this next video that I'm going to be showing you is on probability. Probability is just the probability of having a particular genotype and associated phenotype based on the rules of addition and also the rules of multiplication. So in any particular one event, so one fertilization event, you would use the rules of addition. And with each subsequent mating event, those are independent of each other, and you would use the rules of multiplication. So I'll give you an example of what I mean. Okay, so we will work on this first one, the additional probability questions. So we have one sperm, egg and sperm, that is little a, big A, big B, little b, big D, little d, times little a, big B, and... Okay, so with this, we're basically going to do a giant Punnett square without actually physically doing it. And so in this case, we have something that's polygenic, meaning that this is basically 3 different genes. Okay, so we have one that A, one for B, one for D. Now the question is, what is the probability that the offspring of this cross is going to be big A, big B, little b, and big D, little d. Okay. All right, so what you're going to do is a series of Punnett squares. So I'm going to do the whole thing for you with the Punnett squares to just show you the rules of addition and multiplication, okay? All right, so this right here, since they're independent of each other, these are not linked genes, these are going to influence each other. However, each subsequent one is different. It's a different gene, okay? So let's do this Punnett square. And so you want to do each one at a time. So we're going to do the A's first, and then the B's, and then the D's, okay? So we have A, and then little a. So then we got big A, little a, big A, little a, little a, little a, and little a, okay? All right, so the question is, with these two individuals, what is the probability that they're going to result in this genotype, okay? And so looking at this, there are 4 possible outcomes of this mating genotypes. And there are 2 here, and there are 2 here, right? So that's 2 to 2. So there's basically a 1-to-1 chance, correct? And so how would you express that in a fraction? There's going to be a 1/2 chance that this particular cross is going to result in this genotype, right? 1/2. Let's do the next one. Okay, so we're done. So this is 1/2. So underneath the genotype, just write 1/2, put some brackets around it. We're done. Okay, now we're going to move on to the next one. So that's big B, little b. Okay, so do a big Punnett square. So big B, little b, and then big B and big B. Okay, so that's this cross. So okay, so there's also going to be a 1/2 chance that it's going to be a heterozygote. So 1/2 chance. Okay, so this last one you can actually see the rules of addition, okay? Now these are basically the same event. So this is 1 event, this is 2 event, right? If it's within the same event, you use the rules of addition. And then when we piece it all together, I'll show you the rules of multiplication. So now we're done with this one, okay? So cross that out. Now we're gonna do the last one, okay? And this is where the rules of addition is really gonna come into play, okay? Let's do a Punnett square, 2 heterozygotes. So we've got big D, big D, big D, little d, big D, little d, and little d, okay? And so the probability of having a homozygous dominant is just 1 out of 4. This is also 1/4, right? So this is 1/4, 1/4, this is 1/4, and this is 1/4, right? Okay, So when you have 1/4 plus 1/4 is equal to 2/4, which is equal to 1/2, correct? So do you see how we use the rules of addition? Because this is one event. Okay, so this is one event. So this is also a 1/2 chance, okay? Now, we use the rules of addition when they are separate events. So going back to this is one event, this is one event, and this is one event. Okay, so you use the rules of addition here. So there's a 1/2 chance of getting this here, there's a 1/2 chance of getting this here, and there's a 1/2 chance of getting these heterozygotes here, okay? So now we use the rules of multiplication because these are all separate events. So it's 1/2 times 1/2 times 1/2, which is equal to 1/8. So if you had two parents with this genotype, and the question is what is the probability of having offspring with this genotype, it's going to be 1/8. Okay, let's do the next one. I'm not going to do all of them, but I'll do a lot of them. So the next probability question on the active learning is, oh, it's a larger one. So we have big A, little b, big D, little e times little a, big B, big D, little d, and big E. Okay? So, oh, and then another key piece of information. What is the probability of having offspring that is this? I may not have wrote all these perfectly, but either way, you'll see what the result is. Okay. So here, I'll use a different color pen. This one needs a break. It's my favorite color. Black is my favorite color. All right, let's use this. Oh, blue. Blue's my second favorite color. Okay. So first we're going to look at these. Now so you can do a Punnett square, or you can do it in your head. Okay, so this is a homozygous and this is a heterozygote. So what's the probability that it's going to have this particular genotype here? And I'm going to do this in my head. I know it's 1/2. Okay, again, you can do a Punnett square. That's fine. If you can't do this in your head. Some of you are able to do it now. All right, so what's the probability of little b times little b to have a little b? I mean, there's no choice because that's the only genotype. So that's actually going to be just 1. Okay, so cross that out. The next is 2 heterozygotes. And what's the probability is going to be a homozygous dominant. So if you worked out the Punnett square, you would see that it's actually 1/4. And then lastly, if we have a big E, and little e, what's the probability it's going to be a heterozygote? And again, it's going to be just 1 because that's the only option. And so 1/4 times 1/2 is 1/8. And so the answer to this is 1/8. Okay. So you can go ahead and do the rest of them. There's 4 left, and the answers are on D2L.